Hi Prof, so this is our video for our design final project. So we created a project that controls the traffic which is caused by the left turn lanes at a four-way intersection. We figured that most of the busy intersections have a lot of traffic due to the cars in the left turn lane. When the left turn lane is full of cars, drivers usually wait in a straight line to get into the left turn lane, and this is one of the main reasons why traffic builds up at a four-way intersection. So to come up with a solution for our problem, we created this prototype, which is made out of cardboard mainly. The solution to our problem is that we're gonna add sensors in the left turn lane, which are shown here with these cars, and there's sensors below that. So the system would work like this: if all the sensors detect a car, then the left turn lane would turn on. So as you see, this is a signal for this lane. As you see, there's a red, yellow, green, and the last light is for the left turn lane. On the other side, if all the sensors are triggered, then that means the left turn light would turn on. But if only one of them was triggered, for example, like that, then the left turn light would not turn on. For the purpose of prototyping, we're going to use 5 sensors in the left turn lane. The reason we use more than one sensor is because the current traffic system only uses one sensor, and this only detects the number of cars that pass by the sensor at a certain time. But our system will detect how many cars there are in the left turn lane in real time. So initially we were planning to use an IR sensor or a motion sensor for the sensors in our left turn lane. But the concept did not go as planned, as in real life the sensor would not detect the number of cars there in the left turn lane, meaning it would not detect traffic in real time. To come up with a solution, we had to come up with a different sensor. Therefore, we came up with a custom-made pressure plate sensor. These pressure plate sensors are developed using aluminum foil and cardboard pieces. In addition, these pressure plates are a substitute to an inductive loop sensor, which will be placed in a real-life model. So if we were supposed to implement this on a real road, we were actually going to use an inductive loop, but these sensors are just a supplement of an inductive loop. The reason we're going to use an inductive loop on a real road is because it's much easier to place under the road, and it is more accurate than this pressure plate system. So now I will show you how the wiring is inside our prototype. As you can see, I'm going to lift up my road cardboard and show you the inside of my base. I don't think you can see it properly due to the lighting, but as you can see, there's a breadboard and there's an Arduino Uno, which is our thinking logic for our whole. As you can see, these are the pillars which are supporting our sensors. We have 5 in a row because we have 5 sensors, and this pillar over here is the support which supports the base with the road on top, and these pillars are put along the whole base, which is acting as a support. And this is a close-up of our circuitry, which is shown right here. This is Arduino and this is a breadboard, and a final schematic of our circuitry would be shown in our final lab report. Also, I would like to show you the circuitry of our sensor system, where we have a 5-volt current coming in from the Arduino and a 220 ohm connected to it, and that is connected to an input signal which is connected to the Arduino. And this switch acts as a pressure plate system. So when this switch is activated, that means the circuit is connected. Therefore, it tells the program that it's connected. And if the switch is not activated, that tells the program it's not connected. And this is one of our circuits for our sensor plate. So moving on, now I will talk to you about the time constraints we had during our project. So due to the time constraints placed on the project by the recent global events, our model of the four-way intersection could not be completed. What we had originally intended to create was a four-way intersection with sensor in each left turn lane that would potentially cause traffic. As you see, there is no lanes here as we did not have time to draw them and maximize our full potential. But another shortcoming was that due to the time, instead of 4 light blocks, we had to reduce it to 2 light blocks. So as you can see, there's 1 light block and a second light block. We initially planned to have this and this together in one single block, but you can see there's one light at the back and one in the front. Due to time constraints, we just have to cover up these together and make it separately. And also, as you can see, the cardboard is not painted, so cosmetically it's not finished, and we wish it was painted so it could have looked more realistic. But these are the last minute changes we had to do in order to have our prototype look somewhat completed, as opposed to have an incomplete prototype which would not show a full complexity. So now I would like to show you a demonstration of my project. So as you can see, there's 5 cars sitting on the left turn sensor plates. So as you can see, there's a cutout for each sensor plate, and these are sensor plates on the road. So right now it's a red light, and for the other side it's a green light. Therefore, when the next round comes here, the left turn light should turn on, the last LED. As you see, the left turn light turned on because all the cars are sitting into the sensors. So now if you remove 1 or 2 of the last cars, that would mean the left turn light should not turn on. So when it comes back to the green light, you will see that the light will not turn on. As you can see, when the light comes back to this signal block, the left turn lane would not turn on as there's no cars here. So just now you see the left turn lane is not turning on because but now the green would turn on for the straight line. So this was one of the solutions to our problem, and we feel that we solved a major problem and we completed the objective and the need of the project. Therefore, this is the end of the video of the prototype. Hopefully you liked it. Thank you.